comes to your mind when you hear the word Neptune? For many people with a passing interest in astronomy or space-related things, it is a blue planet festooned with rings and moons. However, Neptune is much more than that, which is why scientists have spent decades studying the planet. They are recording more discoveries, and the new powerful James Webb Space Telescope has helped them to uncover even more terrifying secrets of this faraway planet. What has the JWST discovered on Neptune? How does this amazing discovery affect how we view the whole of the solar system? Join us as we dive into the James Webb Space Telescope's terrifying discovery on Neptune that changes everything. Which planet was discovered by a mathematical equation and is invisible to the naked eye? That is Neptune, the eighth and last planet in the solar system. It used to oscillate between the 8th and 9th planet, but ever since Pluto has been downgraded from a planet, Neptune has remained the 8th and last planet. Uncertainty about its position aside, Neptune is a fascinating planet, even when you get past the electric blue color that stands it out from the rest of the planets. Because it is so far away and not visible without a powerful telescope, Neptune remained hidden from humanity for centuries. However, on the night of September 23rd to 24th, 1846, astronomers discovered Neptune. The discovery was made possible thanks to mathematical calculations of its predicted position due to observed perturbations in the orbit of planet Uranus. The discovery was made using a telescope since Neptune is too faint to be visible to the naked eye. Astronomers soon discovered a moon orbiting Neptune, but it would take more than a century to discover a second one. When Uranus, the seventh planet, was discovered in 1781, astronomers realized there were irregularities in its orbit that Newton's law of universal gravitation could not fully explain. However, they postulated that effects from the gravity of a more distant planet could explain these oddities. By 1845, Uranus had completed nearly one full revolution around the Sun since it was discovered. Astronomers Urbain Jean-Joseph Leverrier in Paris and John Couch Adams in Cambridge, England, independently calculated the location of this potential planet. Using Leverrier's calculations, astronomer Johann Gottfried Galle used the Fraunhofer telescope at the Berlin Observatory and made the first observations of the new planet, only 1 degree from its calculated position. With the help of hindsight, it became clear that several astronomers, starting with Galileo Galilei in 1612, could have observed Neptune too, but because of its slow motion relative to the background stars, they did not recognize it as a planet. The discovery of Neptune's first moon took place only 17 days later by astronomer William Lassell, using a telescope he built himself. However, the second moon was discovered in 1949, known as Nereid. Interestingly, it was at the same time that the first moon officially got its name, Triton. Obviously, everybody thought Neptune would turn out to be a single moon planet like the Earth, and didn't bother to name the original moon. Discovering Neptune's moons is obviously a tedious process, as the third one was discovered in 1981, while scientists were trying to study its rings. More on the rings later. Much of Neptune remained a mystery because of its distance until Voyager 2 performed a flyby. However, there is a powerful tool at scientists' disposal that will lay bare all the secrets of cold Neptune. That is the record-breaking $10 billion space observatory named the James Webb Space Telescope, or JWST. With a radius of 15,299.4 miles, or 24,622 kilometers, Neptune is almost 4 times wider than Earth. For a better comparison, if Earth were the size of a nickel, Neptune would be about as big as a baseball. From an average distance of 2.8 billion miles, or 4.5 billion kilometers, Neptune is 30 astronomical units away from the Sun. 1 astronomical unit, or AU, is the distance from the Sun to Earth. This means light from the Sun takes 4 hours to reach Neptune. A day on Neptune lasts about 16 hours because it takes less time for the planet to rotate or spin once. A year on Neptune, or how long it takes to complete an orbit around the Sun, is about 165 Earth years, or 60,190 Earth days. So no Earthling can witness a complete orbit of Neptune. One of the wonders of the solar system is how sometimes Neptune is farther from the Sun than dwarf planet Pluto. However, there is a simple explanation. It is because Pluto's highly eccentric, oval-shaped orbit brings it inside Neptune's orbit for a 20-year period every 248 Earth years. The latest occurrence of this phenomenon happened between 1979 and 1999. Now, we know what you are thinking at this point, that one day Pluto may crash into Neptune, but that is never going to happen because for every 3 laps Neptune completes around the Sun, Pluto makes 2. This repeating pattern prevents close approaches between the two bodies. Neptune's axis of rotation is tilted 28 degrees with respect to the plane of its orbit around the Sun, which is similar to the axial tilts of Mars and Earth. This means that Neptune experiences seasons just like we do on Earth. However, since its year is so long, each of the 4 seasons lasts for over 40 years. Neptune is the king of moons, although not in the league of Jupiter. Neptune has 14 confirmed moons. Since Neptune was named for the Roman god of the sea, its moons are named for various lesser sea gods and nymphs in Greek mythology. Triton has the distinction of being the only large moon in the solar system that circles its planet in a direction opposite to the planet's rotation. This is known as retrograde orbit, which suggests that it may once have been an independent celestial object before it was captured by Neptune. Triton is an extremely cold place, with surface temperatures around -391 degrees Fahrenheit or -235 degrees Celsius. The moon's thin atmosphere has been detected from Earth several times since and is growing warmer, but scientists can't explain why. Apart from moons, Neptune is one of the solar planets decorated with rings. The planet has at least 5 rings. Naming from near the planet and moving outward, the main rings are named Gala, Leverrier, Lassell, Arago, and Adams. Scientists say the rings are relatively young and short-lived. Neptune's ring system also features unique clumps of dust called arcs. 4 prominent arcs mostly have French names: Liberté or Liberty, Égalité or Equality, Fraternité or Fraternity, and Courage are in the outermost ring Adams. What is strange about the arcs is that the laws of motion would suggest that they would spread out evenly instead of clumping together, but scientists now believe the gravitational effects of Galatea, a moon just inward from the ring, is what stabilizes these arcs. Despite its far distance, we will soon know much more about Neptune thanks to the newest eye in the sky, the JWST. While the primary purpose of the telescope is to focus on faraway objects that tell the story of the beginning of the universe, the JWST will also study the planets in our solar system, and it's already doing so with outstanding results. Jupiter, the biggest planet in the solar system, has already been photographed with the JWST, showing what is possible with Neptune. Scientists are still swooning over the photos as they surpass everything they expected. They are also over the moon by the speed with which images can be produced. This is a process that took days before, but can now be completed within hours. Thanks to its 21-foot wide mirror, the Webb telescope was able to pick out fine details of Jupiter and its large moons. The telescope's instruments gather light at infrared wavelengths, providing a different view than what the more than 30-year-old Hubble Space Telescope has provided. The new image of Jupiter produced by the JWST includes Europa, one of the planet's large moons, which has a liquid water ocean beneath an icy crust. Hubble has spotted what might be plumes of water erupting off the surface of Europa, but scientists will now focus more on this feature. One other spectacular thing about these pictures is how the JWST was able to track objects as they moved fast relative to much more distant stars. The telescope was designed so that it could track even Mars, which moves as fast as 30 milliarc seconds per second across the night sky. During testing, scientists focused on different asteroids and realized that they could still make good science observations on objects moving more than twice as quickly, up to 67 milliarc seconds per second. So what will the JWST study on Neptune? One of them is a strange phenomenon that might get the mining inclined thinking. It rains diamonds on Neptune. With an atmosphere primarily made up of hydrogen, helium, and methane, and high temperature and pressure, carbon atoms could form diamonds and rain down on this planet. Researchers from SLAC National Accelerator Laboratories' LINAC Coherent Light Source (LCLS) even recreated this unique weather event in a laboratory setup to confirm it really rains diamonds on Neptune. However, with the JWST, scientists will be able to do more than recreate. They will be able to explore Neptune to gain insights about the diamonds. How did these diamonds form? One of the scientists studying Neptune explains that extreme temperatures help form diamonds in the atmosphere. When they accumulate and become very heavy, they start to rain down on the planet. But unfortunately, no matter your entrepreneurial spirit, you can't go out there to grab some due to the conditions inside the planet. Scientists have used the Hubble Space Telescope in the past to study Neptune, but nothing comes close to what the JWST will discover. Hubble uses near-infrared and visible wavelengths to look at what's happening in every visible color, but JWST will use mid-infrared that senses a little bit higher than those visible and near-infrared wavelengths, where the interesting chemistry is going on. Neptune and other planets in the solar system are assured of time slots on the JWST thanks to an observation program led by JWST's interdisciplinary scientist Heidi Hammel. Hammel is an STS-CL planetary scientist well known for decades of telescopic and spacecraft observations of Uranus and Neptune, including with Voyager 2. Because of their contributions to the development of the Space Telescope, scientists like Hammel will be granted time to use the JWST to study space. What else is the JWST studying on Neptune? There is a recent discovery on Neptune that has baffled scientists, and they are now waiting on the JWST to provide an explanation. In April, astronomers discovered that Neptune as a planet is cooling down, which was not what was expected. Scientists expected the planet to heat up during its astronomical summer, but as 2 decades worth of data revealed, the planet is cooling unevenly. Scientists hope to use the JWST to find an explanation for the unexpected colder temperatures. But can JWST help here? The world's most powerful telescope can help. JWST's highly sensitive mid-infrared instrument, MIRI, will produce unprecedented new maps of the chemistry and temperatures in Neptune's atmosphere. MIRI will also help astronomers better identify the nature of all recent changes. In other words, get ready for answers to questions that have baffled scientists for decades. Neptune's atmosphere is subdivided into the lower troposphere and the stratosphere, with the tropopause being the boundary between the two. In the lower troposphere, temperatures decrease with altitude. However, they increase with altitude in the stratosphere. You will find hydrocarbons forming hazes of smog in the upper atmosphere of Neptune, and hydrocarbon snowflakes that form in Neptune's atmosphere melt before they reach its surface due to the high pressure. However, one of the things you will notice after landing on Neptune is how cold it is. In fact, you might not have time to notice before you freeze. The planet is one of the coldest in the entire solar system. The coldest is actually Uranus. But just like the Earth, Neptune has its own seasons, which makes it have somewhat warmer spots. The average temperature at the top of the clouds is minus 346 degrees Fahrenheit or minus 210 degrees Celsius. Neptune does not have a solid surface like the rest of the gas giants. The gas just stretches down to the water-ammonia ocean that makes up the planet's mantle. But at the surface, which is the point that the surface pressure is similar to the pressure on Earth at sea level, the temperature is about minus 346 Fahrenheit or minus 201 Celsius. Neptune manages to be warmer than Uranus, which is closer to the Sun, because of the motions of the particles inside it. You will hear more about this movement in this video. However, Neptune has its own summer thanks to the 28.3-degree tilt. This gives the pole about 40 years of warmer temperatures. But that does not mean you can survive these summer years, as the temperature is just about 50 degrees Fahrenheit or 10 degrees Celsius warmer. During this period, methane gas leaks out into space. But this information did not prepare scientists for the strange discoveries concerning the temperatures on Neptune that scientists discovered. Before we get into this discovery, let's tell you about one frightening thing that awaits you when you visit Neptune: wind. Wind is good on Earth. It helps dry clothes and drives turbines to generate electricity. When it becomes huge, it becomes a hurricane, clearing everything from its path. However, on Neptune, it quickly gets out of hand. The planet holds the record for the fastest wind ever in the entire solar system. We are talking about wind speeds of up to 2,100 kilometers per hour. One of the mysteries scientists have not been able to solve is how a cold planet like Neptune can generate such strong winds. Their best explanation is that the cold temperatures and the flow of fluid gases in the planet's atmosphere might reduce friction to the point that it's easy to generate winds that move so quickly. While the deep blue color of Neptune is attractive, many people don't know how the planet got the color. More intriguingly, planet Uranus nearby is blue too, but not as blue as Neptune. Why? The two planets are similar in size and mass, but that is not all. Patrick Irwin, a planetary physicist at Oxford University, and his colleagues have managed to come up with an answer. The team obtained a detailed understanding of each world's atmosphere using the Gemini North Telescope in Hawaii, the Hubble Space Telescope, and other observations. Neptune and Uranus are blue because they have methane in their atmospheres. Methane absorbs the color red from the sun's light, leaving the blue. However, a key middle layer of methane haze on Uranus seemed to be twice as thick as the layer on Neptune, and is the presence of this additional haze that causes the difference in visual appearance. Both Uranus and Neptune would lose haze as methane ice pulled it into the lower atmosphere, falling as methane snow. However, Neptune is more active, causing its own snow to fall more often and leading to a thinner haze layer and deeper blue color. Irwin and co. also try to explain another feature of Neptune, the dark spots that you see on the images of the planet. These spots are as numerous as they are mysterious. They are likely to be caused by a darkening of the haze particles, possibly caused by evaporating hydrogen sulfide ice. And now to the recent in the line of perplexing discoveries scientists have made on Neptune. Ever since the Voyager flew past Neptune, scientists have been using giant telescopes to study the planet. Over the years, they've noted extreme changes in the planet's atmosphere. For example, between 2003 and 2018, average temperatures in Neptune's stratosphere plummeted by 14 degrees Fahrenheit. However, between 2018 and 2020, stratospheric temperatures in the South Pole suddenly shot up by a whopping 20 degrees. It was totally unexpected, which is why scientists are at a loss about what is happening on Neptune. But how do scientists measure the temperatures on Neptune as it is so far away? They track the changes by watching fluctuations in its brightness. Meanwhile, the brightness is not visible to the naked eye because it's in a light wavelength called infrared. These dramatic changes are unexpected because they're happening amid a profoundly long Neptunian season. Remember we told you Neptune has seasons? Well, the issue here is that the temperature changes are expected to occur during different seasons. They're happening amid the planet's southern summer and in the wrong direction. Temperatures are rising instead of cooling down. What could be happening? A group of researchers has said it's possible the sun's 11-year activity cycles may be linked to temperature fluxes in Neptune's stratosphere. Another possibility is that the chemical changes in the planet's hydrogen-rich atmosphere may drive these abrupt alterations. One reason scientists are anxious to solve the mystery is that it will help them understand over 1,700 planets similar to Neptune, which they discovered outside our solar system. They are technically known as exoplanets. There is something else about the temperature measurement taken by the Voyager 2. Obviously, it took the temperature from the outermost layer. At that point, the temperature of Neptune is not so much higher than that of Uranus. But since Neptune receives less solar illumination because it's farther from the sun, this shouldn't be the case. What this similarity in temperature suggests is that Neptune is warmer in terms of how much heat it emits in comparison to the amount of heat it absorbs from the sun. According to Anthony Del Genio of the NASA Goddard Institute for Space Studies, Voyager's measurements show Neptune emits more than twice as much heat as it absorbs from the sun, while Uranus does not. This doesn't make Neptune unusual, though. In fact, it makes Uranus weird because other planets like Jupiter and Saturn also emit more heat than they absorb from the sun. As stated earlier, the progression of temperature as you go farther away from the Sun shows Jupiter to be the warmest of the gas giants, Saturn next, then Neptune. Uranus is the one that is out of place. Del Genio explained the oddity further. Yet that unusual result is associated with the fact that Uranus does not have a significant internal heat source. In other words, Neptune is finding a way to warm itself up to the levels of Uranus, while the latter is unable to generate any extra heat other than that gleaned from the sun. But just what is an internal heat source? In simple terms, it is heat left over from the birth of the solar system when these planets were formed. The heat contracts out of the primitive solar nebula, forming an effect known as the Kelvin-Helmholtz contraction. The extra heat source on Neptune, Jupiter, and Saturn is primarily due to gravitational contraction. As the planet slowly gravitationally contracts, the material falling inward changes its potential energy into thermal energy, which is then released upwards out of the planet. For Uranus not to have such a heat source, something must have happened to it. So the question is, why does Neptune produce heat internally but Uranus does not? There is a possibility that heat is not released from the interior at a steady rate, but instead comes in burps. According to Joshua Tollefson of the University of California, Berkeley, we may just be seeing Uranus in a quiescent period, whereas Neptune has burped more recently. The burps are convection, which may happen in discrete episodes separated by long time periods, but we may not know if it works this way for sure unless we see one of these convective episodes take place. Or it could be an issue of Uranus being an old-timer and Neptune younger. Amy Simon, a NASA senior scientist for planetary atmosphere research at the NASA Goddard Space Flight Center, explains, how much heat a planet radiates depends mostly on how old it is and how quickly or slowly it releases that heat. An older planet would be colder. How quickly they release depends on the interior structure and composition, cloud layers, convection, and so on, and that can be rather complicated. Neptune may be far from the Sun today, but scientists have discovered that it used to be much closer to the Sun, in fact, closer than some other planets. However, this fact remained hidden from scientists for many decades because they erroneously believed that planets remain in the part of the solar system where they were formed, a theory that was shattered by the discovery of exoplanets. It showed that planets do migrate. And this is the story of the origin of Neptune. A study has tried to establish that Neptune, along with other planets, was bound in a near-circular orbit much more compact than what we have today. They were surrounded by a large disk of rocks and ice stretching out to about 35 times the Earth-Sun distance, or just beyond Neptune's current orbit. The study called this theory the Nice model after the city in France where the scientists first discussed it. As Neptune and the other planets interacted with smaller bodies, they scattered most of them toward the Sun. This made them trade energy with the objects, and the result was Saturn, Neptune, and Uranus going farther out into the solar system. Eventually, the small objects reached Jupiter, which sent them bolting to the edge of the solar system or completely out of it. But that is not the end of the strange itinerary. The movement between Jupiter and Saturn pushed Uranus and Neptune into even more eccentric orbits. It caused the latter planets to fly through the remaining disk of ice. Some of the material was flung inward, where it crashed into the terrestrial planets during the late heavy bombardment. Other materials were flung outward, leading to the creation of the Kuiper Belt. While moving outward at a leisurely pace, Neptune and Uranus swapped positions. Eventually, the effects of the remaining debris caused the pair to settle into more circular paths as they reach their current distance from the Sun. There is an interesting observation here. Our solar system could have included at least 2 more planets, but the Nice theory says these extra planets could have been kicked out of the system completely. Where did Neptune's rings come from? The rings of Neptune are very dark and probably made of organic compounds that have been baked in the radiation of space. This is similar to the rings of Uranus, but very different from the icy rings of Saturn. But Neptune's rings seem to contain a large quantity of micrometer-sized dust, which is similar in size to the particles in the rings of Jupiter. Scientists say that Neptune's rings are relatively young because they are much younger than the age of the solar system. They're also much younger than Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. Such a violent origin. NASA scientists are painfully aware that a single flyby by the Voyager 2 is not enough to explain all the mysteries locked in planet Neptune. To remedy this, a group of scientists named Conceptual Exploration Research, CONEX, have proposed a spacecraft called Arcanum. The Arcanum mission is a proposed L-class spacecraft that highlights the revolutionary approach which can now be taken to future space mission design. Weighing in at about 21 metric tons, the spacecraft would be 4 times heavier than the largest deep space probe to date, NASA and ESA's Cassini-Huygens mission, which explored Saturn from 2004 to 2017. CONEX's Arcanum would have numerous components, including an orbiter to study Neptune, a lander to study Triton, and a penetrator to strike Triton's surface and perform a seismic experiment to understand its geology and its structure. The mission could also be equipped with a telescope, allowing for studies of the outer solar system and aiding the hunt for planets around other stars. However, the problem is that there is no existing rocket that could currently launch such a craft as CONEX's Arcanum. When scientists face problems like this, they try to work around them. For example, equipment such as NASA and ESA's upcoming James Webb Space Telescope must be launched folded up and then unfurled. But the process is expensive, complex, delicate, and could be prone to error. A single mistake due to the complexities could send billions of dollars and numerous person hours up in smoke. This is where Elon Musk comes in. Much has already been made of Musk's Starship's human spaceflight capabilities, but the rocket could also revolutionize what we know about our neighboring planets and moons. According to Ali Bramson, a planetary scientist for Purdue University, Starship would totally change the way that we can do solar system exploration. Planetary science will just explode. Scientists are already talking about sending missions to Neptune and its largest moon in the outer solar system, bringing back vast quantities of space rock from Earth's moon and Mars, and even developing innovative ways to protect Earth from incoming asteroids. The Starship, which is being built at a Texas site dubbed Starbase, is made up of a giant spaceship on top of a large booster known as Super Heavy. Both can return to the Earth to be reused, reducing costs significantly. SpaceX has suggested launches of $2 million only using the Starship. With a drastic reduction in costs, more funds can go towards the actual equipment for the scientific experiment or exploration rather than to the transportation. The entire vehicle will be capable of lifting 100 metric tons or 220,000 pounds of cargo and people into space on regular low-cost missions. The volume of usable space within Starship is a massive 1,000 cubic meters. You can fit the entire Eiffel Tower into the Starship payload area when the tower is disassembled, and that's got scientists excited. For example, you can transport a whole drilling rig to Neptune using the Starship and drill down a kilometer as possible on Earth today. This will afford scientists unprecedented access to the interior of the planet. Starships is like wow, says James Head, a planetary scientist from Brown University. In fact, Connex proposes sending the Arcanium to Neptune aboard the Starship. Musk has suggested that SpaceX could launch as many as a dozen Starship test flights in 2022, with missions to the Moon and Mars both on the horizon and plenty of scientific potentials to boot. Once Starship starts flying, the development will be very fast, says Margarita Marinova, a former senior Mars development engineer at SpaceX. There will be so many more people who will be able to fly things. Those could be anything from standalone missions using Starship to ride-along missions on the existing flight manifest. When you have a 100-ton capability, adding on science hardware is pretty easy, says Marinova. If somebody wants to buy payload space, they can have payload space. It will be a really drastic change in how we do science. Because Starship can land back on Earth, it will also theoretically be able to bring back vast amounts of samples. The sheer volume that could be returned from Neptune would give scientists on Earth unprecedented access to extraterrestrial material. That could shed light on a myriad of mysteries, such as the planet's volcanic history. One of the things that makes the Starship suitable for NASA missions to deep space like to Neptune is the method of refueling. Unlike other Super Heavy rockets like NASA's much-delayed Space Launch System and Blue Origin's New Glenn rocket, the upper half of the rocket is designed to be refueled in Earth orbit by other Starships, so more of its lifting capability can be handed over to scientific equipment rather than the fuel. Taking humans to the Moon, for example, might require 8 separate launches, with each consecutive tanker Starship bringing up fuel to the lunar Starship that then makes its way to the Moon with scientific equipment and crew. On a mission to Neptune, the Starship will replenish all the fuel spent during the escape from the Earth and then proceed to the planet on full tanks. Musk is even proposing having fuel depots on other planets where the Starship can stop to refuel, just like you stop to refill your gas tank when on a long trip. This is ambitious, but it makes missions to planets like Neptune or moons attached to Jupiter more feasible and less complicated to coordinate. Let's hear what you think of NASA using the Starship in the comment section below.